Okay, so that's the broad framework. Here we are like, going down one more level to really look at a sort of a pandas table. So in pandas, it offers basically two new kinds of types. Or for type, you can think of it as two new categories of objects, right? These are pandas objects. Pandas understands both of them, so you can supply data frame and series. Now, in pandas, the linguistic is very simple. Data frame is a two by two, no, sorry, a two-dimensional table, n by n. You can have a data frame of n by 1, but that is a data frame type, right? Why we say that is because there are labels here, right? We'll talk about that in a while, but we are talking about data frame versus series. A data frame is a two-dimensional table, has length and width, or rather rows and columns. For series in pandas, it is basically a snake. And why I say that is because it is neither a row vector or nor a column vector. It is not having certain shape fixed. It is so that's why I use this snake, which is of course a kind of Python. Python is a kind of snake. So I'm using snake as a uh, icon to remind me or restrict me from thinking that a series in pandas is vertically aligned or horizontally aligned. No, don't think about that. It's just a sequence. All right, it's a sequence having no particular shape, but one cell is placed consecutively after another. That's true. That's the aspect of positioning the cells that series is offering. Okay, so two kinds, data frame and series. Now, the data frame side of things, just like Excel, right? So I like you to think of data frame as an Excel worksheet. Remember, in each tab of Excel worksheet, you see a table-like thing, and that is exactly how one should think about data frame. Okay, but there is not a very strong analogy because data frame is really a much more powerful version of Excel worksheet. Why? Because just like Excel worksheet, there are row labels that Python call or pandas calls it index. This is the part that I keep getting confused. But after a while, it's sunk in. All right. So the row labels are not called rows, unfortunately. They're called index and not indices. All right. There's no plural form. So it's dot index. So the data frame, this whole thing, right? This whole thing, data frame dot index will give us a series because now this is this skinny form of data representation, this series of labels. Now, I use the word label intentionally, so you will find that I keep saying labels in the index series or labels in the columns series. Why column series? Because dot columns will give us all the labels, all right, in the column, the names of the columns from df, this data frame df. And they are labels because they are likely to be string and they can have any form of representation. It can be integer, it can be a text, it can be a string, it can also be non-unique. All right, so I've illustrated here as a small a, small b, but if we insist, we can end up getting A, B, C, D, E, and then capital A, B, C, D, E, forcefully put in there. Now, it's not going to do us a lot of work or favor by having non-unique column names, uh, but it is possible, it is doable. So same thing, indices, all right, dot index, I'm not going to use the plural form because it's confusing. So the dot index is also labels, and now you get it. Yes, it is possible that they get duplicated. So I could have named them. I can name them as anything, including non-unique labels. So I can name them 010101, and it would still be permissible. There's nothing wrong with that, right? So be very careful about it. Huh? They are labels because we kind of stick a label there, a sticker label. We can change it by sticking another label on it. But it comes with all the do's and don'ts with a label. In other words, we can stick the same label in different columns. We can stick the same labels in different rows, and they are labels, right? So dot index gives us the labels in the rows presented to us, returned to the caller as a series type, so a panda series type, so a snake. And the dot columns, the AF dot columns, will extract out this information and present it back to us as a series data type. So to get so in pandas, we are not going to see the index nor the dot columns, all right, being printed out to us directly. So when we say print df, we will only see the table content, the meat of it. All right. So in some sense, the green column labels and the red index labels, they are there, but they are not immediately readable in that sense. So we have to issue separate commands like dot index and dot columns before we can access them or change them or read them. Okay, so keep that in mind. They are there, but they are accessed with different method commands or functions. Okay, we can always inspect how large or how small each dimension is. How many rows are there and how many columns are there using the df.shape method. So we can say dot shape and inspect this property here, and out comes a tuple of two items. So as in Python, we can always simultaneously assign the tuple values according to the variable names that we put on the left hand side with commas. So number of rows, comma number of columns will give us how many rows there are and how many columns there are in this data frame. So that's very good. How we can now we can have a feel of how big or how small it is. Now, one more thing conceptually that is very important is that pandas data frames are thought of as having labels, all right? But there's also another parallel track to it, if I may say that, right? A parallel track to the columns and a parallel track to the dot index. So this parallel track exists more like a how shall we put it? More like a default understanding that they are always there, but it's not stored. So what is this? Basically, we are going to be talking about. It's not doing what I want. So what is actually this extra column and extra row information? They are basically this. The integer positioning of the columns and the rows. Okay. So they're always there and they're always fixed. And that's why they don't need storage, because by default it is understood. Okay, now we have a very interesting situation. And this is often, from my experience discussing bugs and problems with students, they are often source of confusion and frustration. Right? Why? Because here, let's just look at the column first because it's quite distinctive. When we say dot columns, we get back the label. And later on, we'll learn how to change them. So we can assign values to the column, individual ones. We can also purposely make the column names the same. Although that doesn't serve us any purpose, but we can. What is not possible is to purposely call column number 0 column number 5. So we cannot purposely relabel the column 0, first column, as column 5. We cannot do that. It's always first column, right? Because positioning wise is always first column. So keep that in mind. Pandas is aware that there are two ways to label the columns. One way is by our own labeling. Another way is by default, the integer positioning of the columns. Yeah, so we can say pandas give me the well, the position starting from 0, the fourth column. So then actually by counting, the fifth column will be returned to us, right? Because it's position 4, 0 based. Likewise, we can say pandas return to us the entire third row, position 3, 0 base. So pandas will then return this back to us as a series, yeah, or as a one-dimensional data frame. Now, why is this important? Because there are times when we may want to access the column and rows by the absolute position value. So I want the fifth column, no matter what it's called. I want the even columns, no matter what they are called. Then it would be very nice to use the integer only way, the integer position aware methods in pandas to access those columns and rows. But there are also a lot of business applications where we only are interested in the names because we call them name and age and address, and we're not interested in how they're being stored. Are you storing name, age, address, or age, name, address, or what? We don't really care, right? In that sense, so we just want to extract by name, and that means we'll be asking pandas to access via the green column labels or via the red index labels. Okay, so far so good. Now, always keep in mind the green column labels, red index labels, they are there. We can change them, we can read them, we can access them. Simultaneously, there is also this integer labels for the columns and for the rows. They are conceptually there. They are not physically stored because there's no need to, but all the functions understood that these numbers are there. All right, so we can refer to column by position or by label. We can refer to row by position or by label. Now, let's look at the dot index part a little bit. In this part, it tells us to refer to, let's say if we are interested in extracting the position 3 row, so this part, right, 0 base, remember. Now, you might be wondering, if we read back, if we access the third row by label and by column, by row position, they're actually the same, and that's true, and it doesn't contradict anything, all right? But what is interesting, because now that you understand this part, what is interesting is subsequently, suppose by concatenation, by joining, by whatever it is, we end up having 0, 1, 2, 0, 1, 2, okay? And then it kind of repeats because we are duplicating, triplicating certain standard data frames. You know, we can do that later on. And we end up having non-unique labels. Or maybe the label is just messed up, right? So it's no longer trustable. Or we are reading in from data and the labels there are really not very clean, it's very noisy, and it's very hard to trust. Then what should we do?